Do you get excited about EAS? I don't know. I don't. But there's something to be excited about. You heard about this at the NAB show at the Nautel Users Group meeting. It won an award from Radio World, a Best of Show award. It's Digital Alert Systems, Nautel, and Telos Alliance all got together to work out a way to get EAS on the air and keep it all audio over IP. Plus, take care of a few issues that you didn't know existed. I sure didn't. Bill Robertson is our guest. He is the VP of Business Development at Digital Alert Systems, and he's coming up next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. Howdy, howdy. I'm Kirk Harnack here in Nashville, Tennessee, at the Nashville studios of the Telos Alliance, my full-time employer. And I'm just delighted that Telos Alliance gives me, an hour and a half, 2 hours off on Thursdays to bring you this show. So thank you very much to my colleagues at Telos Alliance. And here we are in the gorgeous spacious palatial Nashville studio of This Week in Radio Tech. I'm Kirk Harnack, and normally Chris Tarr is with us as my co-host. Chris can't make it today. Say a little prayer for Chris. He's under the COVID. He went through the whole COVID season the last few years and never got it. And he picked it up. He thinks maybe on his trip down to Quincy to give a presentation there. So anyway, Chris is not feeling well. Wish you well, Chris, and hope you recover pretty darn quickly. I think he's had this for 3 or 4 days now, so I hope Chris gets better. Meanwhile, I will soldier on with my limited knowledge of the subject, but that's okay. We got a subject matter expert. Let me introduce to you our guest for today, and that is Mr. Bill Robertson. He's the VP of Business Development over at Digital Alert Systems. They make EAS stuff. Bill, welcome in. It's good to see you.
Hey, thank Kirk very much. Appreciate the opportunity to speak with you today and reach out and explain a little bit of the things that we've got going, especially in the technology side of the EAS realm.
Bill, I seems like I met you a couple of years ago on some Zoom meetings with my colleague, Jeff Stedman at Telos Alliance. And we I'm sure we were thinking in parallel with other people like your company, who turns out you guys were already familiar with these concepts. We were thinking, hey, audio over IP is like what we do. And so many broadcasters have moved some or all of their infrastructure into audio over IP. But there's this thing called EAS that makes us sever the audio over IP air chain. And you guys were very receptive to thinking about, we might be able to fix that, and kind of give us a little tease as to what we're going to be hearing about today as we get into the show.
Well, that's right. I mean, one of the things around it is the fact that the whole air chain is really, migrating to a lot of the capabilities and the process and being able to do it in IP. Well, it really formed a kind of a roadblock, because to get it, the EAS message out, you had to take it out of IP, put it back into some baseband audio form, either analog audio, AES-3 audio, and then take it back up. And that's primarily because the EAS device is supposed to be the last element in the air chain, the last switching element, I should say, so that nothing else can usurp it. Nothing else can take over. And you always want to know, you don't want to just feed it into a console and put EAS on one of the faders, because if the EAS message needs to get out, you want to make sure there's nothing blocking it. And so the original conversations that we had, we were talking about what might be possible and things. A lot of it really stems too, where people were talking, oh, we want to virtualize everything. And this concept of trying to virtualize EAS has a lot of other ramifications. So we're looking at trying to say, what could we do that makes the most sense, not only in the context of the technology, but also in the context, in EAS parlance, of the regulations and what's possible without violating or trying to go off and create a whole new set of rules.
Gotcha. So that's those are some of the things we're going to be talking about, and we'll get into a few of the technical details of those. You did allude to the right way to do EAS is to actually insert it in the chain so that the EAS box itself or a bank of relays that it controls for multiple stations actually severs what you're putting on the air and puts itself on the air based upon the rules in the EAS box.
Exactly.
And another way that some people do it, some people with audio over IP with some Axia systems, for example, and I'm sure you can do this with WheatNet and other such things, is to receive a closure from the EAS box and tell that to perform a switch of the sources, like in our world, Pathfinder. And some people do that, and frankly, I've never been comfortable doing it that way. To me, it's like there's a few too many moving parts. But I don't even know if it's legal or not legal to do it that way. But some people do, and they do it reliably. But it depends on something like the Pathfinder program running and executing a script when it gets that closure. I tell you what, we're going to run into our first quick commercial break right now. But I just kind of want to open up, a couple ways that people are doing this right now. At all of my stations, I'm part owner of 14 stations, and we are, in every case, we're coming out analog from an X node, going through EAS relays, and then coming back into an X node. Audio quality wise, it's not a problem, but it does require that, we have to buy an X node or two, depending on how many stations we have in a particular market. We're spending several $1,000s just to get analog audio out and loop it right back in. From a quality point of view, I mean, the Axia X nodes have a noise floor down around 102 dB down. So it's not a quality issue. Although I'd like to, keep it digital the whole way just because I'm an engineer. But we'll talk about that and what you guys have come up with along with Nautel and Telos Alliance to solve this. Hey, we're here with Bill Robertson. Our show is brought to you in part by Nautel. Isn't that a coinkydink? Nautel is doing this really cool thing where they are offering up an HD radio trial. HD radio trial. Check this out. In the HD radio trial, it's a test drive. So you can get into HD radio. Let's say you haven't done it yet, and a lot of stations haven't. In fact, of my 14 stations, we just did our first HD radio last summer. I just put that on the air. The trial wasn't available then, but we're doing with all Nautel stuff. HD radio, if you haven't tried it yet, it has the potential to create critical presence on your car dashboard and to help your station stay competitive in the field of alternate media choices. And these have been in the news a lot this year and in previous years too. So it's all based on Nautel's software-based air chain technology. It allows you, the broadcaster, to try HD radio transmission in your market for up to 6 months to unlock listeners and content and new revenue potential without needing to install and purchase $40,000 or $50,000 of HD gear. So it's an easy, minimal cost option to turn on HD radio transmission. And you can try a lot of things. You can counter competing alternate media. You can see the impact on listener retention and engagement when album art or graphics are displayed in your auto dashboard. You can get real-world market data based on up to 6 months of trial time. And what you need to get started, you need to lease or purchase a Nautel GV2 FM transmitter, or you can upgrade your GV transmitter to a GV2. Talk to your Nautel rep on how to do that. You also need an Xperi main station or equivalent license, an assigned trial agreement with Nautel, and of course you need some content. 1 to 4 channels. We just put up a station in Oxford, Mississippi, home of Ole Miss University. So we got lots of young folks hanging around there. We put up an alt rock station on our FM and HD1. And we put up an oldies on HD2 and a light urban station on our HD3. And we're loving it. I mean, the audio quality is absolutely fantastic, and we're a Class A FM station, so we didn't have a big transmitter requirement. And I'm using Nautel's software AirChain, where we're using the Multicast Plus box to do that. You can do that too, and you can do it actually a little cheaper than we did it because of this digital radio test drive from Nautel. Contact your Nautel rep in the middle of the country. I know that is Jeff Welton. And y'all know your Nautel rep. Check it out. You can go to nautel.com and get in touch with them and find out who your rep is and find out about this test drive. Thanks, Nautel, for sponsoring This Week in Radio Tech. All right, it's Kirk Harnack. I'm along with Bill Robertson from Digital Alert Systems, and we were just talking about the challenge of incorporating EAS. Bill, I got one more thing to say, I guess, before we get into your explanation of how this idea works. As a broadcaster, who most of our stations, we're able to get emergency alerts, especially weather alerts, on the air. We contract with outside weather companies that update our weather right away, and we're able to get the actual National Weather Service information in spoken word, spoken by typically a meteorologist, either automatically by word parsing or by sentence parsing and assembling words, or by a brand new feed that comes in right away. I guess what I'm saying is, even if we didn't use EAS for weather, my stations get weather on the air right away. Now, our competitors in our small markets that we're in don't do that. They're on Sunday evening, they're still running Friday's forecast. And that's not good. And so they're not handling tornado emergencies. So I guess what I'm saying is it's possible for broadcasters to be responsible and to get emergency information on the air, at least weather information, without EAS. Now, there's plenty of reasons why we want EAS to work. We want it to work well. If there's a chemical spill at the munitions factory up the road, and the county officials need to get that word out. Hey, evacuate the area north of Greenville, Mississippi on Highway 1. Well, we need to get that out. And we want to be part of that. So anyway, I guess I have a little bit of a love-hate with the EAS. I want it to work well. Oftentimes in the past, when it worked poorly. And we even, years ago, when we started we put up some new stations and we had a statewide test, and we aired an ad for a dry cleaner in Jackson, Mississippi during the monthly test. And it's good to know that if we have a dry cleaning emergency in Mississippi, by golly, we're covered. We'll get it on the air for you. So will the LP1. All right, enough of my negativity. Talk to me about how EAS can work better and lead us into your solution.
Well, actually, you actually presented some pretty good things, and it is important to understand too. Lots of times when people talk about weather and where the source of the weather, National Weather Service, things like that, great sources for that, but they only provide weather. And some of the things that you want to be cognizant of, or further relate things, are perhaps things like radiological hazards, fire warnings. We've had other things like that where, the Hawaii fires and whether they did it right, things like that, but still child abductions, all the things that are non-weather are other parts that EAS can really help participate in there. And I think a lot of the stuff too that you'd mentioned earlier too about the signal flow, the process, the up and down and conversion, things like that, can have a real impact. Not necessarily just because of audio quality may suffer. Again, converters are pretty doggone good, but why add more equipment? And that's one of the things. If we can simplify this, that's one of the key areas that we've got. So really, we took a look at this whole idea of the air chain. What's necessary? What do we have to do? What's the optimum way that we might be able to participate and do this in the right way? And really, when you look at it, if I could get that first graphic popped up, just to get people to understand what we were talking about. So the promise here, or the premise, if you will, was to try to take the EAS device. It's listening not only the LP1, LP2 that it's monitoring that way, but remember too, this is also monitoring cap feeds, whether they're state cap feeds or the FEMA IPAWS feed, those kinds of things. Looking for alerts, and we set up the alert information, and then when the alert needs to be forwarded, when it's rises to the occasion that it is an alert that we want to forward, we need to route it through this network. We're going to go over audio over IP, but I need to route it because I need to make sure that my audio, in other words, my emergency message, gets to the output, and that's out to the transmitter. So this really kind of is the very, very simplified idea of what we're trying to accomplish. How do I get my alert when it's generated and it rises to the occasion to be forwarded through whatever routing mechanism is and keep it in a network-based idea, so it's audio over IP to my output. And that's really kind of the starting point.
I'd like to point out something. Once in a while, somebody will make a complaint about routing through the network. And what they're wondering, well, is that as reliable as if I have my EAS, at the transmitter site or just before my audio processor? Well, you're using that network that's in the blue cloud in the middle there, and that's really your audio over IP network, probably at your studio. You're using that 24/7 anyway. I mean, that's what everything else you do goes over. So it's no less reliable for putting an EAS message on the air than it is what you're depending on anyway. And maybe what I just said is just thoroughly obvious, and it probably should be. But once in a while, I'll get somebody complain, "Oh, I wouldn't trust my network for EAS. I want that to go." No, you're trusting it for everything else you do. So let's run your EAS through that as well.
I mean, the thing is that typically, and Kirk, you're right. I mean, if someone is, putting their expensive content, ads, and everything else through that, and all of the quality that they have associated with that, we're using the similar kind of thing. It's really a representation of, we're just leveraging the technology and trusting that the technology is working for everything else, which should work perfectly fine for this. And that's exactly what we found out.
Perfect.
So
Okay.
when we look at this, as I kind of represent that first graphic as what the concept is, what we're trying to do, we move to the second one. And the second graphic just is a very, very simplified thing. Again, this is the traditional one. We talked a little bit about this, where I've got my audio playout system. I've got to either down convert it or whatever, because the last thing in my air chain is this EAS device. That's going to be my switch. There's your classic example of how it works. That goes out, it switches, and if an EAS alert again rises to the occasion, it switches in, takes over the signal, and feeds that into the output string, which is the modulator and the transmitter. Now, when we take this a little bit further, and you can kind of see this graphic, there's a big space in between it, because there are typically some other devices in there. When we expand the air chain and look at the other things, because this becomes another important part of it. So if we go to the next graphic, you can kind of see that this fills in the extra spaces. So even though we've got the EAS device, it's the last switch in the air chain. That's the important thing. It's the last thing that takes an alternate, the potential for taking an alternate signal feed, and then we move it through the rest of the air chain. Well, this is where, if you're an FM station, you're doing the PPM encoding for Nielsen. The audio processor is in there. If you're doing RDS data, all of these other devices are down the air chain to the output. So we look at these things because, in context of what's going on, there's some other real neat things that we can do. But the idea is, how do we get that switch? And that's the thing. That switch is the thing that was thwarting us from being able to implement this. We've got to get it into an audio over IP format, and we've got to get rid of that traditional switch and use a different form of technology to be able to do that. So when we looked at this thing and started to put that, put these things together, we said, okay, what is the right implementation here? And really what we did is we landed on something pretty straightforward in our mind. And that is, if we go to the next graphic, if you will, kind of virtualize that switch. And virtualize that switch means I'm going to send an AES 67 or an audio over IP stream out of my EAS device when it raises to the occasion, but I'm also linking it with a routing protocol. And this kind of goes back into a thing like, why am I doing that? Well, one of the things around it is, I've got a device, this LiveWire device is capable of having multiple inputs. You talked about X nodes. There's other devices that can source multiple inputs from consoles, everything else like that. But what I need to do is I need to tell that device, hey, I've got an alert. I need you to get out on air now. And I need you to take it from this output. So we send that routing information into the LiveWire device, and essentially we have now taken the traditional relays or other switches that are in the EAS device and placed them in the air chain. So everything around this now is an AES 67 audio over IP air chain, from the beginning, play out, everything else, The EAS device switches that in all the way through the output. Now,
Bill,
the other thing
I've got
about go ahead.
Yeah, I have a question that relates to the previous slide and to this one too. And it's always dogged me. It's always been a question in my mind, and you can clear this up. When EAS came out, and when the first boxes came out for that, and we were shown, hey, run your audio through this box. It's got an audio in, it's got an audio out, and eventually, at first, it was just a dry pairs for stereo audio, and then it would interrupt, perhaps with a relay, and it would stick the proper EAS message in the output, and then when it was done, it would return that relay to the looping through audio. And at some point, a company started building ones that would do AES EBU digital audio in and out, and that was well and good. And then for stations that we have one EAS box covering multiple stations with similar coverage areas, similar EAS areas, we could have a slave bunch of relays that would switch several stations all at once, but do the same thing.
Yep.
And we were always shown in the manuals or in FCC information, this is how you hook your EAS in. Now, some of us thought, well, that must be legally how I must put it in there. It must be the final arbiter, the thing that decides, and it's got to be left up to that box. And other people said, well, no, you could control something else. Like I mentioned earlier in the show, some people tell a program like Pathfinder, hey, make this routing change. And then when it's done, go back. So I wonder if you could clear that up. How much of this was just practice because of the technology at the time this came out, and how much of this might be a legal precedent? No, you need to hook it up this way so it's 100% sure. How should I think about that?
No, actually, that's an excellent thing, and it goes way back. It goes back further because a lot of the other things, and this is one example. There's another thing around this that we've been doing for years, where obviously, as you kind of pointed out, the state of the art and the simple way to hook this up was, as I showed, in the traditional air chain. Take your audio output, plug it into the box, take the audio output of the box, plug it in your transmitter. That was it. It was simple. It was, you didn't have to think too much about it. Very straightforward. But as we advanced into the other capabilities, there is nothing written in the rules that say you can't play this in another way. In fact, we have interfaces with automation systems where instead of generating the audio ourselves, we send the automation system a file. And the automation system can figure out where in the playlist. So let's say, for example, I've got spot, and then right in here, I can insert the EAS message and play it there. So that way I don't have any breaks in it. I can figure out the right content. As long as I play the alert within the time window that is designated for it to play, if it's a standard EAS message, it should play within 15 minutes. A required monthly test, you have 60 minutes in which to forward the message, those kinds of things. All of that is possible. It does not have to play from the EAS device, but it has to air. Now, one thing that we do with those systems is if another device airs it, we require, on our side, that device report back to us, and we put it in our log, so you don't have to go look at a station log and try to reflect that against your EAS log. And that's one of the important things too, is the fact that you've got the logs are going to represent who played it and when it played and when it aired, because those are the things that the FCC are concerned about. But there is no absolute requirement that says this device must be the last device. It must be hooked up in this way. There are a number of different ways in which we can accomplish the same mission.
Okay. Well, that makes good sense. And I'm glad to know that in in a few places we have hooked up to where a weekly or monthly test would be delayed until the first, natural program break. Of course, tornado warnings, you don't delay those. We put those
right
on the air immediately. Okay, good. Hey, it's time for a quick break. When we come back, we've got a lot more to study about that last diagram that we saw with the AES 67 audio and the live wire routing protocol. And we got a lot more to explain. Bill's got a whole bunch of stuff to talk about here. It's coming up. Our show This Week in Radio Tech with Bill Robertson with Digital Alert Systems. It's brought to you in part by Broadcast Bionics and the incredible idea of the Bionic Studio. Very flexible. We're going to show you a lot of stuff in the next 2 minutes here, and you can kind of pick and choose the functions that you'd like. Hey, engineers, you want to be a hero to your on-air team? Check this stuff out. We'll be right back.
Welcome to the Bionic Studio. The Bionic Studio brings all audience interaction to the fingertips of a production team in radio, TV, and podcast. Our workflow-led system is working 24/7 around the world for small broadcasters and national and international networks. Our telephony module, Bionic Talk Show, allows cost-effective centralization, remote operation, scalability, and resilience across an entire network of stations, but at the same time is used in single-studio self-op environments. Social media curation and activity is now considered a broadcast-critical part of programming. Bionic Social means the studio isn't overwhelmed with a wall of interaction from an ever-growing number of social platforms. We combine SMS, MMS, and email together with a speech-to-text service for listeners using smart speakers. We enable studio teams to curate, filter, and display all platforms in one place, and post text, images, and video content to multiple platforms in one operation. Effortless collection of video content with Bionic Director has helped position some of the world's most successful stations as leaders in viral content, generating appointments to listen and free marketing via retweets and shares. Bionic Contest enables end-to-end tracking of on-air competitions, live reads, and prizes. These can be on-air contests, automated SMS entry, or online. Anywhere, and Skype TX for Radio brings high-quality audio and video contribution into the studio with ease. No need for dedicated PCs to run different applications. Everything is controlled within the Bionic Studio UI, and incoming connections are visible to users along with all other platforms. Our codec integration enables connection, algorithm configuration, and directory to a wide range of IP and ISDN codecs. The Bionic Studio, a unique suite of products designed to enable your talent to work smarter.
So many cool products from Broadcast Bionics, including the Bionic Studio, and also the virtual rack. It's so cool. Check them out. Thanks a lot, Broadcast Bionics, for sponsoring This Week in Radio Tech. And if you, the engineer, implement some of the stuff at your station, you're going to be a hero because you get lots more stuff produced, especially for social media, and almost no extra effort. Just pretty cool stuff. All right, we're here on This Week in Radio Tech. I'm Kirk Harnack. Chris Tarr sadly is out. He is recovering from COVID, but he will eventually feel better. I know he will. He says he feels better today than yesterday. Our guest is Bill Robertson. He's with Digital Alert System. He's the VP of Business Development. And to me, Bill, are you really an engineer? Because you talk like an engineer.
Yeah. I have a BSEE, so yeah, I guess I have that to bear on.
Well, good. And just to give folks a little background, I was at the beginning of the show. I mentioned that I met Bill a couple of years ago when we had some talks within Telos Alliance, and my colleague Jeff Stedman and some people in the EAS world. Digital Alert Systems was very interested in talking about how can we make the technologies all work together better. And then at this past NAB show, Digital Alert Systems made a big announcement along with Nautel and Telos Alliance about this technical collaboration. Now, what you're seeing in this episode is the technical explanation of that collaboration. Bill, you had to feel pretty good on stage at the Nautel users group, the NUG meeting, explaining this concept to everybody. I mean, and then to receive the big Radio World Award, the Best in Show kind of award. That had to feel pretty good, didn't it?
Absolutely. I mean, there's no doubt. And the biggest thing is the recognition and acknowledgement from your peers. It's not just the fact that you got up there and did that, but that they recognize that this really was and is a true innovation. We're not just trying to do something. We're not just playing with it. It's not just something that was, oh, hey, it was obvious. There is a lot of real technical elements of this thing that need to come to bear. And I think that a lot of people say you actually led off, okay, hey, this might be easy. I can take an audio output, put an AES 67 converter on the output, and oh, look at that. Now I've got AES 67. But that's where things fall down. And again, part of the stuff, if I can call up that slide 4.
Yeah, the one we were looking at before.
Yeah, exactly. There's a little subtlety in that thing that if you notice that that live wire routing arrow is bidirectional, this is an
Hmm.
important distinction. I'm not just taking and handing a dongle on the output and just voila, I've got AES 67 output. That routing protocol and the management of that is one of the important steps. In other words, that live wire device, an X node, whatever it might be, the critical thing is that something else can try to take over. In other words, I'm in the middle of something. I'm running an EAS event, but my automation system says, I need to go to this other input. We have to monitor that device to make sure, again, that nothing is going to overtake us. Why did we do that? Well, again, in the traditional way of doing EAS, nothing can override us because we're the last thing in the air chain. Well, in
Yes.
this particular thing, that we virtualize the switch and we're no longer the switch, we still need to manage the switch or that device as if it were us. And that ability to know what the state of the switch is, or if the state changes, that we can then, when we're done with the EAS, if we were supposed to be on a commercial break or we're supposed to be at another port or another mic, we can switch it back to the state it's supposed to be in. So that
Yeah.
part of the thing is not just, hey, I send a contact closure. No, this is a true knowledge of what's going on and directing that device based on other inputs that it might be receiving and the state that I'm supposed to return it to. So it's a subtle thing showing a bidirectional arrow, but it has a real big impact on if you're going to do this right. And that was
If
one of the things around this.
if I could tease what's coming up for just a second, and yeah, this is what's cool. If you apply the correct principles to make this work, which is what you just showed, that bidirectional link, so that you tell the routing to take place for the EAS, and you monitor that routing to make sure nothing else changes it. And if something else tries to, you say, no, you can't have it. I'm still doing EAS right now. What's cool is that, and I love this about audio over IP, and I love this about IP in general. If you solve the problem correctly and intelligently, it may turn out to be that you can do lots of other stuff too. And I won't. I'll keep the powder dry, and you can explain it. But once you get that part right, which you've done and explained right there, there's some cool things you can do that all just fit right into the equation. So, please continue.
No. That's perfect. So again, if I'll just kind of go on that graphic one more time.
Yeah.
We looked at that. We've got that. But as we looked at this further, we saw there's other devices down the air chain. And so, in solving that one problem initially, what else could we do to improve EAS overall? What are the other things that might be impacted by that? So, what are the next one? If you look at this thing, the next thing in the air chain is the PPM. And here's the thing that makes it interesting. If my alert originating station is already sending information that has a PPM watermark in it, and I pick that up and I retransmit it, again, I'm just forwarding the alert. I've already got their watermark from my reception of their alert, and I put it through my PPM encoder. I now have double encoded it. That's a problem, because the issue is that I don't want to have double encoding. I've already received it from my primary origination station. I should just pass that on. Now, people might argue the other things, but here's another critical point. What we should do is disable my local PPM encoder and just keep the original PPM through it. This is just for EAS. It's not going to have a major impact, but what we don't want to do is screw up the logs and the other things around it. There's another one too. That next thing in the line with the audio processor. EAS is a monophonic, repeat of audio. It's not a stereo thing. It's a dual channel mono type of presentation. It's audio in its best. You're not going to get music. There's not a lot of dynamic range. So the thing is that what we may want to do is also trigger the audio processor to have a template or a way that is best suited for EAS. If I'm a music, a rock station or things like that, I can have it switch to a preset that is better suited for properly having the EAS audio in it versus my standard content. So the neat thing about this is we're looking at this air chain, shutting off PPM, turning and sending a command to the processor that can give us a much better flow of this important information through the air chain. And so part of the thing around it is look at this thing in not just in the simple context of, oh, I did AES 67, I got a switch on it. What else can I do to improve it? And that was some of the things that we did. So part of the stuff that we really went forward with here was to really try to showcase this in a number of different ways. And if I can get you to kind of switch, I think to our slide 5 here, or 6, might be our next one here. And this kind of represents an even bigger thing where what we have referred to this as EAS at the edge. And when we talk about edge, we're talking about edge devices. So we've got this EAS device at one edge of our network, kind of like we had showed in the original thing, and the other edge is the transmitter. Now, in this diagram, you're seeing one more thing, and that's the RDS encoder. Again, when I looked at that entire air chain, what can we do to improve it? Number one, we've now virtualized the switch with a live-wire device. We're monitoring the switch with the routing protocol. We've disabled the PPM encoder so that we don't double encode. We've reset the audio processor to a template that is better suited for it. What about RDS? And for years, this has been one of the things that radio guys can do that no one else can do. TV guys, they have to put a crawl up, but they don't want to leave the crawl up. They need other things. RDS lets us put the text information of the alert into the air chain. We can send the information. People can read what it is. We can send information into this thing in such a way that now we have the text part of it so that people that have an RDS enabled encoder or decoder that can see that, they can actually read what the contents are. There might be some important information. A phone number to call in the case of a child abduction would be presented on the screen. The license plate number of the van that the child might be adopted in can be presented on the screen. People can see this stuff. And now using an additional protocol, the LiveWire protocol for routing and control of the other devices, but EASnet is a protocol that we developed for box-to-box communication that allows us to send additional data into this air chain so the RDS system can also present this.
Wow. Okay. By the way, on that RDS encoder, would your DAS box need to talk directly to that, or could it talk to some middleware that a lot of people use to aggregate several sources that they're going to choose to what goes on the RDS, or even take that middleware and send a correctly parsed text out to their stream and another one to their RDS, maybe to another one in RDS in a different market? How can that EAS net talk to different things?
Well, it's great question too, because EASnet is a separate protocol, and therefore it actually lets us on our box, we can target up to 8 different devices, so they can all get different content. We can filter it in various ways and present it in such a way that other devices that might be maybe further controlling the RDS with the stream content, we can send the data to them. So all they have to do is be EASnet aware. We can give them information about how to do that, how they can parse the data set and present it in certain ways. I'm representing kind of the simple thing about if it's already built into the air chain, we can send that to that, but it doesn't preclude us from having other devices able to maybe take over or do another, additional jobs on that task.
Gotcha. Okay, cool. And it seems like if there are people who make middleware, a lot of my stations use free middleware called Magic RDS that comes with the Pura brand RDS encoders. But it seems like people could who make such middleware could add inputs or filters, for EAS at the edge, for your protocol, because they've already added a bunch of
Absolutely.
others. So. Yeah.
Absolutely.
Okay. Oh,
and that's
shall
the
we?
thing about,
Shall we? Go ahead.
I was going to say that's one of the things around it. We haven't really stopped anything. We've just are kind of showcasing what can be done. This is one of the real things around it is how could we innovate this? And as you mentioned before, we started this process a couple of years ago and looking at this and trying to understand it and bring it to the forefront and recognizing, hey, we really can do some pretty interesting and exciting stuff here to overall improve EAS as a presentation. And there's more. I'll talk a little bit more about some additional things that can be done as part of it and what we really kind of showcased at NAB with the different manufacturers and our group. So right now, the ability to have all of these things with different protocols or different elements and data being in there, we've now kind of filled that air chain. We've done the thing all the way through with each of the devices that are down there. And the thing is that some of these things are, separate boxes that you might have or independent types of applications that might be running on that. But one of the things that we did that was very exciting and what we showcased at NAB on our booth and on the other stand is a lot of those elements, the LiveWire device, the PPM encoding, the audio processor, and the RDS can be found in a single device. And in fact, the Omnia 9, if we go to the next graphic, represents that many of those devices are all encompassed in one single device. The Omnia 9 has all four of those things in one unique kit. So
that's right.
I can set them up as separate boxes, but what's neat about this is we can also look at this as an integrated solution, and all of those elements are there. And what's neat, guess what? All of these controls, everything I'm showing here is over an IP. I'm representing them in different logic elements in these red lines, but it's all over IP. The audio is coming in over AES 67 as one protocol, LiveWire routing as another protocol, and the third protocol is EAS Net. We stack the protocols and look what we can do.
And that can come over one cable, one Ethernet connection. Yep. If you're using something like an Omnia 9, which has all that built in. Wow, that's mind blowing. Okay, one cable, and yeah, I'm familiar with the Omnia 9. I've set a number of them up, and yes, I don't use PPM encoding anywhere, but you can get that, as a plug-in or as an easy in out. So wow, that's really cool.
Don't let your mind blow yet, because there's more.
Okay, well, tell you what. Tell you what, we're going to have to take another quick break. That's part of, hey, if you're watching or listening to the show, it's free to you. And that's because we're going to tell you about a few things. We're talking to Bill Robertson. He's the VP of Business Development and an engineer over at Digital Alert Systems. And he's got what I thought was just great news when I first heard about this whole implementation. See, I was part of the original talks a couple of years ago with Jeff Stedman and Telos Alliance. And then, I had other stuff to do. They were talking amongst themselves. And so I went off and didn't hear anything about this until just before the NAB show, and they said, they're going to be showing this. That's so cool. Hey, This Week in Radio Tech is brought to you in part by Broadcasters General Store, and one of their amazing, of course, vendors, manufacturers that's been around for years. You know them and love them, and that's Henry Engineering. And Henry Engineering for years has made the stuff that you just got to buy and put in because it's so much easier and safer than trying to lash up your own nonsense. And one of those things is the back UPS. Now, the back UPS, you'd think this is a simple little box, but it's got a couple little additional things that Hank Landsberg built into it. This box is ideal when you've got equipment in a rack, like I do at my stations. I'm sure you do too. You've got equipment that you need to run all the time. You can't stand it going out of power. And maybe you've got all those items. I've got a bunch of playout PCs and an EAS box and a couple other things in a rack, and all those devices that I have only have one power supply. I've got another rack at this station I'm thinking of everything's got two power supplies, and of course that's easy to handle. One goes to a power strip with commercial power, and the other one goes to the power strip with UPS. But if you've only got one power supply, of course you're going to run that big power strip to a UPS. But what happens when you got to change the batteries on that UPS, or you got to do some other kind of maintenance, or you're futzing around with the menu on the front of the UPS, and you accidentally turn the thing off, or put it in battery test mode, or something like that? Oh, that could be a nightmare. Oops, I just knocked 4 stations off the air. Gee, that's happened to me. Well, the back UPS will solve that for you. It's got 2 power inputs. One of them is the input from your UPS. The other one is an input from your commercial source of power. Now, normally, the UPS input is what's passed along to the duplex output on the other side. But if that input from the UPS, if that goes away, voila, it's an instant changeover to the commercial power. And that way you can do that maintenance on the UPS. You can replace those batteries. You can accidentally screw up, testing the batteries like I have. And your stuff will stay on the air. And oh my goodness, I have put this to the test, accidentally and on purpose, both. And each time it's worked perfectly. Now, the back UPS, this is not a big, huge device. It's not meant for running racks and racks and racks worth of stuff. I think it's rated for 15 amps? Yeah, it's rated for 15 amps. It'll run your computers and things that are in, a rack typically. And that's how I have mine set up. This is just, it makes so much sense. That's what Hank Landsberg does. He builds things that, gee, I should have thought of that, but he builds it really nice, thinks of a few cool things to go in it, and gives you some, extra features in there. Like this has a delay time for returning to the UPS. Hey, do I do it right away or 10 seconds, or do I wait a while to see how it's going to go? It gives you a status output too. You can tie that into your remote control if you'd like to do that. This thing is just awesome. It's the back UPS from Hank Landsberg at Henry Engineering. And of course, where do you get it? You get it from Broadcasters General Store. BGS.cc is the website. The phone number, 352-622-7700. You can look it up right there, or you can do like me and just memorize it. I think I've been dialing that number since probably 1991. When I was working with Sam Phillips in Memphis, Tennessee. Great people there. Great sales team. Awesome people. Sharp pencils, too. Good discounts at Broadcasters General Store. Thanks, BGS, for sponsoring This Week in Radio Tech. And thanks, Hank Landsberg. Appreciate you, too. All right, we're talking about EAS, and we're talking about keeping it all digital with audio over IP. Our guest is Bill Robertson. Bill, let's roll right back into where we left off. We got a graphic going on here with the Omnia 9. That's a cool surprise. And I think the Omnia 9, it can be standalone, but can also be, like you show in the graphic here, but can also be included in an Autel transmitter like the GV2.
Perfect segue. Thank you very much. And if we just go to the next graphic,
well,
here
there you go.
You actually see, there it is. I mean, Kirk, you kind of knew it, and that was the whole thing. This is where you really see the power of the whole this idea of EAS at the edge. We have the EAS device at the edge. In other words, and part of that stuff is important because the critical thing about being at the edge is people would say, "Oh, I want to hook up. I can hook up remote receivers, and I can take my audio and pipe my audio to my EAS device in a remote location." The problem there is you're adding more complexity. You're adding more devices. You're adding more things. Really, with this thing is we're putting that decode logic where it needs to be, and that means that, remember, this device is only going to trigger when it has something to say. So why not put the decode logic at the edge? In other words, where I can sit there and monitor those LP1s, LP2s, know what's going on with it. And then if I have something to say, I can communicate via IP to the rest of the system. And that also lets me put this in a distributed mode so that I can put my edge device, my DAS deck, at a far remote edge, but still pipe the information necessary into, let's say, a central cast location or into wherever my studio equipment might be. So the neat thing about this edge is that we've got one edge, the DAS deck at the other edge, the routing stuff that we talked about, which we're going to come back to in a bit, and then the final thing is the transmitter. Now we're seeing IP from the EAS device right into the transmitter. EAS device right into the transmitter. And the beautiful way that Nautel has organized all of these elements into one device makes it all work extremely well and more. So remember, we have got the Livewire routing protocol already built into the Nautel, the PPM encoding, the audio processor, the RDS, and the FM modulator, because there's more stuff. The neat thing about the GV2 is it's an HD radio system, which means I have multiple streams. My HD 1, 2, 3, all of those things now are combined. So I've got 4 outputs, one EAS device, and I'm able to put the information out on all of the different channels of this thing. So it really puts this together as a very, very integrated solution. But wait, as the old adage goes, there's more.
Oh, wait, there's more.
One of the things that we did, if you'll notice, there's an additional link showing EAS net going into that last box, the FM HD modulator. Well, what's going on in that particular thing? Here's where we really have done something, and the guys at Nautel just stood up on this thing. We developed, as part of a group called NVISA, or Next Generation Video Information Systems Alliance, we developed a system, or I should say a series of symbols, of graphics that are representative of each of the different type of EAS alerts. So one of the things that we can do is we can send into the Nautel system what is the alert type, and it can generate the alert graphic to embed in the HD output. So we replace for example, we might replace the album art and put a graphic that represents what the alert is about. If we will switch to the next slide, and you'll kind of see this is an actual representation. This was a BMW motorcycle on the Xperi booth at NAB, and it was tuned to the Nautel transmitter. So when we were sending this thing out, that graphic, that little symbol, it was a test. But what's neat about that is here's the HD radio out. We've got a regularly scheduled program thing that's reading, but we're giving that vid symbol, that triangle that you see there is the vids, that symbol. And we've got that now. Again, this is the type of thing. One, it might be the text, but we're looking at this thing in the context of maybe, English isn't the first language, or what can we do to further represent what the alert type is? And those symbols can then be popped up to represent the alert type. This is simple. It was a test, so it was a little green with an ellipse in there to represent. It was just a simple test. But we've got a series of symbols for each and every EAS event with different color coding, if it's a watch versus a warning, and represent them. So someone could look at that and immediately understand what it is that's going on, and if they need to pay, better attention to the particular event. These things are really cool, and this is something that the EAS net message into the Nautel transmitter further lets us do. And we can do this again on every one of the HD outputs on that thing. So when you look at this thing in the overall context of being able to represent the EAS message in an audio format, but also represent the EAS message in a text format with RDS, and as a symbol for people that, again, may be challenged in reading the text. Obviously, you're driving, it might be a thing, but you can quickly glance over and see if it's something that is of importance that you have to do. The other thing, again, that radio guys can do is they can leave that graphic up. So, for example, if I let's say I'm in a store, in a shopping mall, no outside windows or anything else, I don't know that I'm under a tornado warning. I go outside, yeah, it's cloudy and things like that. I get in my car, I start my car. Guess what? I can have that graphic up there representing that I am actually in a tornado state. I missed the alert. It came out maybe 2-3 minutes before I got to my car. But if I leave that graphic up and leave it persistent for the duration of the alert, just because I go wonk, 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 and I give you the EAS information, that alert is still valid for some period of time, maybe 2 hours, maybe a half hour.
Right.
Why not leave that symbol up during the duration that the alert is still active? And by being able to do that and communicate this level of information, radio guys can do something that nobody else can do. And it's really kind of an impressive capability that we represented. We showed it. Here it is in absolute form. This is an EAS, an HD radio receiver on a device, and it's representing the graphic element as part of that particular thing. So to us, this really showcases the power of a air chain, and an air chain that we can control and add additional value into this, the whole representation. If you want to be known in your market for, who is innovating and who's leading this stuff, those that can give you the best information are the people that they're going to go to.
Does this imply, this graphic that can stay up, can it prevent the return of album art until the period of time that the alert's over?
That's a function that's programmed by the Nautel side, whether they have persistence for the duration. But part of the EASnet message that we send them is what's the valid time window for this alert.
Gotcha.
So again, if it's a tornado warning and it's valid for 2 hours, they can set it up to say, hey, I want to leave that up and not have it replaced by album art for the duration of the alert. Again, that's a setting on the other side. But we present the information from our side saying, hey, we've got this. Here's the information. How you want to deal with it could be adjusted on the user side.
Okay, cool. All right, I think we have one more graphic here to look at. Do we?
Yeah.
There
so
we go.
really, going back to that very beginning, when we talked about this EAS at the edge concept and what the premise was how do we get that input, that EAS device, through this network of routing information to an output? And we really have done it represented in essentially 3 protocols. They're all IP protocols. AES 67 is the audio over IP protocol. Livewire as the routing protocol, so we know to make sure that this signal gets to the output no matter what, and make sure it stays there no matter what. And then the final one is our EAS net protocol that sends ancillary data. This is the information for RDS, the information for VIDS graphic, the information of the duration of the alert. All of those things can be represented, and we now have the edge device, the input side, and the output side represented now and working. And again, you kind of pointed out, Kirk, this was one of the things that we won a Radio World Best of Show award, representing this level of integration and this kind of capability that really can take a whole nother element that we've been sorely missing in this thing, and getting into a thing where we can do a lot more and a lot better.
I want to return, if Suncast could help us out here, and go back to graphic number 4, the 4th graphic. I've got a follow-up question on that, and I think I know the answer. We noted that all those blocks from Livewire device, PPM encoder, audio processor, RDS encoder, all of those things. Well, and if you use a Nautel transmitter, the GV2, you also get the modulator all in one block. But if you think about the Omnia 9, that Livewire device at the left-hand side, there's an IP audio driver that's running within the context of an Omnia 9. And I believe, Bill, that you mentioned that you don't have to use an Omnia 9. That Livewire device could be something like an Axia X node or something else that would respond to Livewire routing. If you're using an X node and not an Omnia 9, you may not get, functionality of those other functions, which may or may not be so important to you, but at least you get the routing. So tell me about using, say, an X node instead of an Omnia 9.
Absolutely. And in fact, the neat thing about it is the Livewire protocol supports both. And so that's absolutely right. In fact, all of our development initially was done using X nodes. And so the idea is having the X node, and the way that X nodes work, again, with consoles and things like that, because you may not, Omnia is a great product and everything else like that, but you may have a different PPM encoder, audio processor that you like in your environment. But the thing is, so you could use those. Again, those boxes and how we kind of represented it, how they were grouped together, they just happened to be grouped that way. Very simple, very straightforward. We can use an X node. We can use different types of X nodes to be able to represent this depending on what your inputs are. And in fact, the way that whole kind of ecosystem for Livewire works, it's very simple, because what we're looking for is that last node that we can tell it, hey, whatever else is going on, we're taking over because we've got an EAS event that needs to play out. So again, that flexibility with the thing you had mentioned before about your RDS middleware, there might be something else to be able to do that. So there is nothing that precludes that it says it has to be this way. But what we're doing is we're representing that this is one way to do it, and different groupings might be the best for your station or your operation, how you may want to do that. It's just really showcasing what's possible out there.
Yeah. Could you? We're going to take our last commercial break in a minute, but I got one more question. Maybe you could address. Could you talk to me about when you instantiate a route change for the duration of the EAS message, and you make sure that nothing else interrupts that? Tell me about what you guys can be aware of if something else tries to. What do you return the audio to when the EAS is done? Do you return it to the state that it was in, or do you return it to the last thing that something else told it to do, or how might you work that logic out?
Did you want to take the break, or I can address it right now?
Well, yeah, let's address it now, and then when we come back, we're going to have our tip of the week.
Okay, no problem. So, really, one of the things that we're doing is because, as I indicated, we're constantly monitoring that input. If something else comes in there and tries to take over, we look at what that state change that they are trying to move it to, and that becomes the new state that we'll return it to. So,
Ah,
if there is a route change that comes in, either again by automation or by user wanting to make a route change, we can look at that because we're monitoring what's going on. There's a number of different devices that can talk to that LiveWire device. All we're looking at is
mhm.
we need to understand what the state it's in when we first go there, and then any state changes, we're going to grab those and say, okay, when we're done, here is the last state change that it goes to, and so we can make sure that if it's a play out server that we should be in, then what we do is that's what we return it to. And that's again
So,
why we're constantly monitoring that.
This makes total sense. And you know what? The chances of having that conflict are kind of small. But if you did have that conflict, let's say that we came to the end of music programming before the ball game starts, and we're going to go live to the stadium. But an EAS came along right before the ball game. So we're in the EAS at the same time we would have switched, maybe automatically, to the ball game. And we want to know that when we're done with the EAS, we're going to go right to the ball game. We're not going to go back to the automation because it was the ball game or something switched or wanted to that's going to put the stadium on the air. So that makes total sense that you're taking care of this, even though it's kind of an edge case. It's an edge case that needs to be addressed, and sounds like you have.
Well, that's it. And the whole thing around that is it's always the case. When you start looking at that, you can find the simple thing. Oh, yeah, we can just send it. And again, that's why I said if you just wanted to put a dongle on there and say, ooh, voila, I'm AES 67, that's not sufficient. And that's why we
Yeah.
looked at this thing. And quite frankly, as you said, I mean, this has not, been, hey, oh, this was a simple thing. It's taken us quite a bit of time and development, working with Telos as a partner, working with Nautel as a partner to really suss out what are these things that we need to pay attention to so that we get them right.
I,
And that was
you know,
kind of
and
the whole thing.
I gotta have you maybe mention just one thing. This whole concept of this kind of operation, I didn't realize until you told me before. This was not entirely new to digital alert system. You guys have done some similar things in the television world to this kind of all digital operation, isn't that right?
Yeah, absolutely. And I guess kind of the funny thing for us is we're seeing the radio guys actually finally catching up with TV. We've been doing this in the television market for a long time. And this EAS at the edge concept is not something, that even though we've kind of coined the phrase now in the radio space, we've been doing it for a long, long time where we've got an edge device sitting out in a market monitoring the LP1s and LP2s, the sources that we have for, that particular area. And then over IP, we send the alert information, so that it might be a full screen slate. It could be the audio part or even the text information into a central cast location. And there, what we do is we feed an encoder directly. So there's a number of video encoders that have graphic engines in them. In other words, they can generate the crawl, and we send the audio as part of the stream pipe that we're doing it, and we're talking directly to the encoders. The other edge, that's not a transmitter in that particular sense, but the video programs are encoded, and you've got different encode levels, whether I've got a .1, .2, .3 in a particular market.
Mm-hmm.
We do this. We've done it with the cable market forever. And in fact, that was the whole thing is the cable guys, were the precursors to a lot of this stuff because they needed these things in their environments long before anybody else. So the cable side of it, the television side has done it. And now it's really cool to see the radio guys catching up and recognizing that this technology is available to them to be able to do it. Again, the benefits of central casting and other things that can be seen from these types of things really make it a slick setup.
We're talking to Bill Robertson. We'll be back with a tip of the week from Bill next, right after our last announcements. I want you to know that our show is brought to you in part by Angry Audio, and it's shipping, folks. The Rave console from Angry Audio. Suncast is going to show you some really pretty video here. He's going to turn the audio down just so I can kind of talk over it there. Look at that. Look at that. Kind of Oh my goodness, I can talk in kind of a cool jazz kind of way. Look at that beautiful console. It's amazing. You get easy installation with Studio Hub RJ45 connectors for your inputs and your outputs, XLR inputs for mics, built-in power supply. There's no wall wart here. Mic and line remote logic, warning and user tally outputs for on-air lighting signs and enunciators. You get preview or Q on every channel, silky smooth faders, avionics style switches with LED illumination, slick low profile desktop design, and this thing is just absolutely gorgeous. Really flexible monitoring controls. Now, this is an analog console, okay? It's analog in, analog out. There's no digital here, but it's perfect, for a small studio, for a podcast studio. It is absolutely sumptuously gorgeous. And I mean, this thing is heavy. It's got a beautiful case that it's in lovingly encased in. It's just a gorgeous console. This is the Rave analog console. It's the best of show winner at the 2024 NAB show. So check this sucker out from Angry Audio. You can go to angryaudio.com. You can also get this console from your favorite Angry Audio dealer, and there are plenty of them. Thanks a lot, Angry Audio. Thanks for shipping this thing and for designing such a beautiful audio console. Our show is also brought to you by Max Connect and this super cool device. It's a USB interface, but it's the only one like it in the world. It really is. It's the Max Connect U192 MPX USB sound card. What does that mean? Well, if you're like a lot of people and you're using one of these new audio processors that runs on a PC, so I'm talking about things like the Omnia SST or Stereo Tool or Breakaway One, and you want to come out of your PC and get that into your transmitter, there's a couple ways to do that. One way is using micro MPX, and that's a technology that's out there and been out there. But if you want it locally, right there at your PC, let's say you want to feed your transmitter right there at the PC, or if you want to feed an analog composite STL, use this beautiful U192 device from Max Connect. This is really the first USB audio device that's purposely designed to give you 192 kilohertz composite output, DC coupled all the way through. This is the right way to do it. It also gives you analog or digital AES EBU inputs, so you can feed into your computer with this same device. And it's powered. It's not powered over USB. It's powered by a real power supply, and then it connects to the computer that's running your FM processor via USB. It's designed by Angry Audio for the folks at Max Connect, and I'm telling you, this is the cat's meow if this is the kind of audio processor setup that you want to do. This is just so freaking cool. It's just amazing. I love it. If you want to get one of these, go to maxconnect.com. I know it's spelled funny. We'll have a link in the show notes, or call your favorite dealer, your favorite Max Connect dealer, and they should be able to hook you up, or get it directly from Max Connect. Good folks. All right. Appreciate you sponsoring This Week in Radio Tech. All right. We got just another minute or two with Bill Robertson from Digital Alert Systems. Bill, I asked you to come up with a tip of the week, maybe a nugget of information to carry away from today. What might that be, sir?
Actually, one of the things I would say, and I highly recommend everybody do this, all of the modern EAS devices, ourselves and others, have the capability of having an email output. What you should do as a backup, as a redundant thing, is always set your device up, set your station, create an email account that's, WYYY or EAS at WYYY.com, whatever it may be. Set up an account that your EAS device can send its logs to. There's different things about what's going on, but what's nice about that is it's automatically backed up through your email account. You've got a redundant thing. If anything were to happen to the device, whatever else, you've got that kind of a backup. Use the email function that are built into the modern devices to be able to kind of create that redundant log, because that's what the FCC is looking for. You want to make sure, and by the way, Kirk, that was one of the things too, is that early on people, you had to have a paper tape, a paper trail. No, the FCC just said you have to have a log. And we were the first ones to pioneer, got rid of the old paper things and said, well, you can't do that. No, you can. You just have to have a log. And if it's electronic, they actually prefer that. But make sure you've got that redundant backup. It's very simple. Use the EAS, the email function out of your EAS device, set it up, and you've got kind of that built-in backup. Every time there's an event, you could go there and you have a separate email account for it.
That is a great tip. A great tip. Thank you so much for that. Cool, Bill. We're out of time. We've used up every minute of our time. Yep. Thank you so much for spending an hour and 10 minutes with us today. And if people want more information on this concept, award-winning, I might add, Nautel and DAS and Telos Alliance all shared in this award from Radio World. Where can you read more and get more information about this?
We've got information on our website at www.digitalalertsystems.com. Information there. We've also got some presentations. Nautel has done it on the NUG, and Telos has a really great whole list of things on their site with their blog. So we've got the graphic elements. We've got some other things that people are able to see. And then if anyone wants to, you can contact me, bill.robertson at digitalalertsystems.com. And thank you very much for having me on this week.
It's been a pleasure. Real pleasure to have you on, and thank you for explaining this so well. I mean, I feel like I understand this really well now. It was a great review for me. Bill Robertson, thanks again, and it's good to have you on the show. Hey, we got to go. We're going to have an interesting 4th of July show for you next week. We're going to talk about a new LPFM. I know it's some people not excited about LPFM, but you talk about the emotion of putting a new FM station on the air. We've got some we got some cool people that are going to get together and do a multi-person show for you. Probably going to record it Monday next week and play it back for you on the 4th of July. So it's going to be a cool show. Big thanks to Suncast for producing today's show. Thank you, sir, for being at the controls and getting this thing all done. And we got to go. So we'll see you next week on This Week in Radio Tech. Bye-bye.